Hey, welcome back to Math Qwest. All right, today I'm going to show you how to be able to tell if a graph or a table is a function. All right, and this will be the easiest way ever. You'll be a master at this after you get done with this lesson. All right, let's get started. Let's look at the first table, table A. What we want to focus on is the inputs. And why? Because the definition of a function is for every input, there is only one output. Every input, only one output. All right, so let me show you what that means. If I look at my x values, and my x values are always my inputs, I'm going to look for any numbers that repeat. That's what I'm looking for. So I see a 7, -2, 0, 4, 9, -3, and 6. None of them repeat. Therefore, I do not have to proceed with my checks of the outputs. This is a function. Okay, because it doesn't matter what my outputs are because there's nothing else to check. This is a function because they only used every input once. Let's take a look at the second one, our second table, table B. Again, let's focus on our inputs, our x values. 3, -1, 2, 0, 1, 2, and 9. So as you can see, they used the 2 twice. They used it right here and here. Now I proceed to do my second check. I want to check the answers. For the first two, for the first input of 2, they used, the answer is 9. The output is 9. But the second time they used the 2, their answer was -8. So I have 2 different outputs for the same input. So therefore, I would say that this table right here is not a function. Okay, that is not a function. And remember that this was a function, the other one. So this is not a function because I have 2 different outputs for the same input. For the same input of 2, I get 2 different answers. All right, let's go ahead and skip the graphs and let's go straight to the next table. If we look at the table, this is just a vertical table, no big deal. So again, I'm going to focus on the x values right here. And I have a -8, 4, 11, 6, and -8. So the -8s repeat. The first -8 has an output of 11. The second -8 has an output of 11. So they both have the same output. So therefore, this is a function. Okay? It is a function. That almost looks like a 5. Woo! All right. Simple enough. Hopefully, you're getting the hang of this. Now, let's take a look at the first graph. And when I say graph, I'm talking about this circle. This is the graph that is on my coordinate plane, right? On this. So this is the coordinate grid and this is the graph itself. So what I want to do is use a vertical line test on this one. Let me just grab a, I think they're here. Yeah, we have a line. A vertical line test is just what it sounds like. A vertical line going across my graph. You can draw it anywhere. You can draw as many as you like. So let's put that line there. And now I'm going to ask myself, how many times did my line touch my graph? So I see it touched it once there. It touched it another time there. Because it touched it more than once, this one here is not a function. That is not a function. But let me take it a step further. Let's say that, well, I'm going to show you how it connects to a table. Oh my goodness, look how crooked these lines are. Just look at like my students' work. Just messing with you guys. All right, pay attention here. So my outputs, well, first of all, my inputs, my x values. Let's look at the inputs. This on the x-axis are where my inputs are. So let's just estimate. Obviously, that's not a 1 since the 2 is way over here. But let's just say that if that input was a 1, okay, that would be this. They're putting in a 1. Let me use a different color. 1. Well, what is my output for that 1? My output will be right here. And that's right in between 0 and 2. So that is a 1. So when they put this input of 1 here, they got an output of 1. But notice, for that same input of 1, they got an output of -1. So again, they did it again, and they got a -1 the second time. So I want you to see how this table relates to the graph. The same input, 1 and 1, but 2 different outputs, 1 and -1. that is not a function. So hopefully now you can see how the table relates to the graph, right? It's the same values in there, they just look different. All right, so let's take a look at our next graph, graph D right here. Now here they have dots, right? Now every time I give this assignment in class, kids like to go ahead and connect the dots. Do not connect the dots, okay? If they wanted the dots connected, they would have connected them themselves for you. This is what is called a discrete graph, where the dots are not, or the points are not connected by a line. Otherwise, it'd be called a continuous graph. So this graph is fine just the way it is. Again, you can do a vertical line test. It doesn't matter. So if I did a vertical line test, for instance, across this dot, as I go through the entire grid, did I touch any of the dots? No. Did I touch any there? No. Any there? No. And as you can see, I'm only going to touch one dot every single time. So that's how you can do a vertical line test on the discrete graph. You can do vertical line tests and you can see you're only going to touch one dot per line. So therefore this is a function. All right, hopefully it's becoming easy for you. I tell you what, why don't you go ahead and pause the video and do this last one right here. Go for it. So did you try the vertical line test? Here we go. Here's my line. Boom, vertical line test right there. How many times did I touch the graph? One time, and that's it. You can see that anywhere that I would draw a line, I'm only going to be touching the graph once. Now my lines are kind of slanted, especially this one, but it only touches once. So therefore this one is a function. All right, so hopefully you can tell now you can determine whether it's a function or not by looking at a table or a graph. And most importantly, if you got value out of this video, please hit the like and subscribe button. All right, make sure you subscribe so you see the new videos as they're coming out every year. I'll be making these I make these every week. Oh my goodness, I've been making about 3 to 4 per week. All right, so if you want to become a master of math, keep watching my videos, and I'll see you next time on Math Quest. Have a good one. Bye-bye.